Hi everyone, this is Ms. Page. In this lesson, we are going to go over again how to calculate average rate of change. We're going to do so this time for models that are polynomial, so polynomial function models. So I want to remind you that average rate of change, remember, is a calculation of slope. What we're doing is we're averaging all of the slope values of a piece of a curve, because as the function curves, its slope changes. So what we do is we take an average using the 2 points at the ends of our interval, calculate that slope, and use it as an average slope or an average rate of change for that particular interval. So remember that your slope calculation is the change in y values divided by the change in the x values. Here it's written in our function notation, where it shows change here means subtraction, and that we have to understand our interval values, which are defined from x of 1 to x of 2. So when we are finding an average rate of change, you want to make sure that you identify your interval values, which would be your x values, and then you can find the corresponding function values. That may be from a graph, from a function, or from a table. You want to make sure that you pay attention to the units for your x and your y values in the context of the problem. Take those values and plug them into your average rate of change calculation, which again is your slope calculation. Notice here it says what I just said, include units for the numerator and denominator. Literally put those into your math. That way, it'll be very easy for you to know what your units should be for your conclusion. Because then afterwards, given a context problem, we have to explain what that average rate of change means in terms of the context. And as I was just saying, be sure to include the units of measure. Make sure you understand that the units of measure for an average rate of change should be a rate or a ratio of units, such as feet per hour or dollars per month, something like that. All right, let's take a look at this particular problem. So here, you also have to, of course, recognize that you're doing an average rate of change problem. A big key, of course, is the use of the word average in some way and the description of two values that would represent your x values. So here it says that the graph shows the height of a butterfly over several minutes as it flies through a park. We are to approximate the average speed. So here's speed is a type of rate. An average speed then makes this an average rate problem. So we've got an average rate of change problem. So we're to approximate the average speed of the butterfly as it's flying, specifically from 7 minutes to 11 minutes. So notice our time in minutes are the x values, or if you preferred, you could call them t, since no variables are specified here. And we can see here that our y values correspond to height in feet. Remember, that height is the butterfly as it's flying through this park. So we are to, when we get to the end of this, if necessary, round to 3 decimal places. So here's a good place to point out that this would be a problem in which a calculator is appropriate. So you are allowed to use one for this problem, or for these problems in this lesson. All right, so first thing we want to do is make sure we understand what the values are in our interval. And those would be x values. So they have to be time in minutes. And so that's what we have here. So we have an x value of 7 minutes and an x value of 11 minutes. And you can give them subscripts if you want to, like so, but just so long as you understand and keep track of which x's and y's go together, that's up to you. Then we're looking at figuring out the corresponding y value. So a strategy that is good to use here is to find the point that corresponds to each of these numbers of minutes. So here's 5 minutes, here's 10 minutes, so this would be 7 minutes. So that would be the point right there. And for 11 minutes, this would be 11 minutes, so that would be the point right there. And take and draw a nice horizontal line segment from that point to your y-axis. or even across your y-axis, like so, and like so. This will allow you to, those are not really horizontal. Let's try that again. Let's see. That looks a little, no, it keeps moving on me. There, it's a little better. There, that's better. So now I can see this is my y value here. That's approximately my y value there. So I'm looking at my scale. If this is 0 and this is 20, this scale is going by 5. So this would be 5, this would be 10. Having a hard time drawing it there. This is 10. And then this, of course, would be 15. All right. So what we're looking at here, if this is 0 and this is 5, that looks like it's about at 4. So that would go with our 11 minutes. So that's our y sub 2 would be 4 feet. And then our y sub 1 that goes with our 7 minutes here is, if that's 10, probably about 14. All right, so now we are going to set this up, finding our average rate of change. So it's the change in our height, because that's our y values. So we have a change in height over the change in our minutes, because those are our x values. So I like to start with my sub 2's because my x is larger, and that makes my denominator positive, but as long as you keep things matched, it's okay. So I can do 4 minus 14 feet over 11 minus 7 minutes, or I could do 14 minus 4 feet over 7 minus 11 minutes. Both would be correct and give you the correct answer. So either way, I'm going to go back to this one. So this is going to give me negative 10 feet over 4 minutes. So as I was saying, when you put your units in here, here are going to be the units, feet per minute, of our final answer. We're going to want to simplify this, and negative 10/4 is negative 5/2. That's negative 2.5. I am going to use my approximate symbol here, and that is because we estimated our y values, remember? So we are technically approximating, even though I'm not having to round that particular value, and this would be feet per minute. So I've got that, so now I am going to write my conclusion. So this is an average speed of a butterfly in this case. So the average speed of the butterfly I want to make sure that I include my interval, because the average changes if I change my x values. So this is from 7 minutes to 11 minutes. Is about or approximately negative 2.5 feet per minute. You can also explain that negative in terms of the context, which means that the butterfly is descending. So you can actually see that on this interval, that the butterfly is heading in the downwards direction. That's what the negative is referring to. So that means that it is looking at a change in height in the downward direction as time progresses. All right, let's try a practice problem. So here's your practice problem. Pause your video. All right, let's take a look at the answer. So here you hopefully concluded that in this case, the first 2 seconds means that we start at 0 seconds and stop at 2 seconds. So we're looking at this point here, which would be a height of about 2.5 meters. And then at 2 seconds, this would be about 30 right here. So if you said 28.5, 29, those would be good. And then here, setting it up for the change in height over the change in seconds. And we're looking at here then about 13.25. Again, we are technically estimating or approximating, even though this has an equals, because we did have to approximate our heights. So then here's a possible conclusion that includes all the necessary information. During the first 2 seconds, the plane is ascending. That means that it's climbing or it's heading upwards, like so, at an average speed of about 13.25 meters per second. All right, let's move on. All right, now for this problem, we are looking at having to use a function in its symbolic form. So we have this function here, v of t, and we are told that it represents the value of a company's stock in dollars, that the t represents a number of months. So we are here to find the average change in the value of the stock per month. And we're to do so here from 1.5 to 4 months. All right. Where the previous problem didn't necessarily require a calculator on this type of a problem, definitely an appropriate tool. So we have to first understand that this would be our interval. Our t values are like our x values, the independent variable. So t is like x. And we have our t values here of 1.5 months and 4 months. So again, you can give them subscripts or just keep track of which one is which. And our y values are our function values, v of t. So I'm just going to call it v in this case. What we're going to have to do is calculate each of them. So we're going to have to figure out, well, what is v of 1.5 and what is v of 4. So plugging that in, we're going to get 2 times 1.5 to the 5th power minus 32 times 1.5 to the 4th power plus 176 times 1.5 to the 3rd power minus 384 times 1.5 squared plus 288 times 1.5 plus 5. All right, let's figure out what that is now. All right, so plugging this one into our calculator, we get 20.1875. Now remember, this is the value of the company's stock in dollars, so this would represent a dollar amount. All right, we repeat that process for our value of 4 months. So we've got 2 times 4 to the 5th power minus 32 times 4 to the 4th plus 176 times 4 cubed minus 384 times 4 squared plus 288 times 4 plus 5. And this one gives us $133. Exactly. All right, so now we have our x's and our y's, and again, we need to make sure we understand that the 133 goes with the 4 months, and this 20.1875 goes with our 1.5 months, and we can plug it in to our average rate of change, which is the change in our dollar values divided by the change in our time in months. So again, like I said, I like to start with the combination that has the larger x, so that my denominator will be positive. So that would mean in my numerator of $133 minus the $20.1875. Notice I didn't round that, no need to. I'll round at the end. Here I'm going to get, so I'm going to do the math here. I get, you can do it separately, so I have 112.8125 in dollars divided by 2.5 months. If you do it all at once in your calculator, do make sure that you put parentheses around both numerator and denominator. All right, and then dividing, we are looking at 45.13. Now here, we should know that rounding would be to the hundredths place. That's our pennies right there, and that this would be dollars, and this would then be per month for our units. And it is still an estimate, but it's not an approximate dollar amount. This is an exact dollar amount to the nearest cent, but it is an approximation of the change in the value. So the way I would word this one, let's take a look at our prompt here. So find the average change in the value of the stock per month from 1.5 to 4 months. So this time I'm going to start with my interval, which is also something I often like to do. So from 1.5 to 4 months, it is estimated. So this is how I'm saying that I'm doing an estimated change in value. So it is estimated the stock value will change, or you could even say increase in this case because it is a positive value, at an average. Never forget the word average in your conclusions in these problems. At an average of $45.13 per month. Not overall, but per month, like so. All right, let's try a practice problem. All right, here's your practice problem. Pause the video, give this one a try. All right, let's take a look at the results. So here your interval was 2 minutes to 4 minutes. Your value for 2 minutes should have been 40.92 miles per hour. Your value for 4 minutes should have been 22.84 miles per hour. So set it up this way, or if you did 2 minus 4 in your denominator, then you should have 40.92 minus the 22.84. And it should have come out to a negative notice. And so we have a change in negative 9.04 miles per hour per minute. So from 2 to 4 minutes after the car enters the road, it is actually decelerating. It's slowing down at an average of 9.04 miles per hour per minute. Or what you could have said, I would be fine if you could just say that this is what we're looking at here, the car's average acceleration. So an average acceleration of about, well, it's actually not rounded, so let's take out that word about. An average of negative 9.04 miles per hour per minute. So if you want, that's fine. If you can at least explain that that is your average acceleration. All right, that ends this lesson. So give your assignment a try and have a great day.